Okay, so we're going to start looking at some 2.7 ideas. 2.7 is limits at infinity. So we're basically going to kind of focus on what's going on a graph or a function as x's get really big or as x's get really, really negative. So we're going to look at a couple examples here. First example, suppose we had a graph like this, and let's say at 2 we have a horizontal asymptote, and we have another one down here at -1, and our graph does this sort of thing. And so what we want to say here is, let's say that this graph is f of x. We want to know what is the limit as x approaches infinity of f of x, and what's the limit as x approaches negative infinity of f of x. So, as x's get very, very large and head off towards positive infinity, x's are basically, we're letting our x's run along here. We say, what are the y values doing? Well, the y values are following this part of the graph, and this part of the graph is starting to approach +2 here asymptotically, meaning it's these y values get closer and closer and closer to 2 as the x's go off towards infinity. So in this case, the limit as x's go to infinity, the y values of the graph approach 2. And we say, okay, well, what about negative infinity? If x's are heading towards negative infinity, so if the x's are going this direction, well, then the y values are heading down here, and the y values are approaching this second horizontal asymptote, which is down here at -1. So the limit as x approaches negative infinity of f of x of this function would be -1. So let's look at an exponential function. Let's call it g of x. And let's say g of x starts out here, and then it starts to grow exponentially, and we have kind of one of these nice exponential curves. So we want to know what's the limit as x approaches negative infinity of g of x, and what's the limit as x approaches infinity of g of x. I did these backwards from the way that they were in that other one. Let's do the infinity first, and then negative infinity second, just to keep it the same order as what I had it in on the previous thing. So we say, okay, what is going on as x approaches positive infinity? So as x gets bigger and bigger and bigger, what are the y's doing? So as x's get larger and larger and larger, the y values are peeling upwards in the exponential function. They're growing larger and larger and larger. So this tells us that our y values in this case are going to infinity. The bigger the x value you get, the y values just increase without bound, so they head up to infinity. As we go to negative infinity, x's are heading along the graph like this on the x-axis. And the y values come down and they start running alongside the x-axis. So as you head to negative infinity on this exponential function, your y values come down and the y values approach 0. Okay, and then the last one we're going to look at is sine of x. So if we have the graph of sine of x, let's say it's just, there's that, and then it just keeps doing that over and over again. And we say, what is the limit as x approaches infinity? And what's the limit? It's fourth period now, I think, right?
Huh?
The fourth period? Or? Yeah.
Or no, fifth.